maybe we could get started with the UDF sync. Thanks to everyone for joining. This is first sync after New Year. And I think overall, we have a huge amount of discussion already on the UDF spec, and PI has been there for a while. Overall, the structure is look good, and we've talking most about how we do the overloading within one UDF definition, as well as a bunch of different call conventions, like how do we handle the non-values, how do we do the positioner invocation, name the parameter invocation, default values. Today, maybe we might focus on two topics. First, I think there's a little bit of controversy on the global name list. I write a small doc for that. We can take a look and see which one is we want to go. We just, once we make the decision, we just go with that. And another one is the default value. I don't have a doc for that. I think the default value itself is a little bit more convoluted. Depends on the call convention from engine side and the definition of UDF itself. For example, how do we avoid ambiguity? Because when you have different call convention, like position or name the call conventions. So if we are okay, say we can push postpone that to the next phase. Definitely fine with that as well. I'm gonna share that doc for the global name list a little bit. Let me know if any question right now.
Sorry, I looked away for a second. It sounded, and I missed the specific comment about pushing something to the next phase. I'm assuming you're saying, like, do we need to push default values or something to the next phase because it's causing problems? I think we're at this point where we can get through this, and if we get through it in the next week or two or something like that with some effort, we'll be much better off than if we were to push it to, you know, a later phase or something like that. Just because we know that there are systems that support this, that it makes a lot of sense to support it. And I'm just hoping that we can figure something out, because I feel like we're so close.
Sounds good. Cool. Yeah, that's exactly what I'm saying, whether we should push the default value. Okay, let's focus on the global name list first. Let me share my screen a little bit. All right. Here's this Google Doc. Is it too small? Should I enlarge it?
A bit, yeah.
How about that?
That seems good to me.
Okay, thanks. Sure. I think we're talking about the global parameter name list, especially when it comes to whether, like, it comes to the invocation called name the parameter invocation, where every time you call a function, you can say X, if function parameter has X, Y, and you can say X equal to something, Y equal to something. So in that case, you don't care about position at all, because you can switch to, even you order is X, Y, and you can switch to Y equals to something and X to equal to something. So position doesn't matter in that case. So that's caused some problem, because we have multiple overloads, and the original design is each single overload is going to have their own name. And the one overload could name X, Y, and the other overloads can name Y, X. Then it causes confusion when the engine try to pick up one function to call. So I think Ryan come up with this idea a few weeks ago, but how about we have a global name list, so that invocation of the when it comes to pick up one overload to call, the decision will be more deterministic. Like, you know, the order of that, you know, the order of all these names, and it's sequential, like it's always treat X, Y, Z. And then in that case, it's much simpler just to follow the convention when it comes to named parameter calls. So this is definitely a pro of the global name list. There's something like there's some feedbacks about is it too restricted, because looks like when I look at all these engines, including programming languages, almost nobody's doing that. I'm not saying it's a bad thing, but nobody's doing that actually at this moment. So I came up some examples. Say, okay, there's some restriction on with the global name list. Here's the first example is if you have different types and you like kind of naturally you want to use different name. It is possible especially in the like Java and the other programming language, you want to use string or array and you want to use different names. And if we say, okay, for this particular the UDF, because there has multiple overloads, one is for array, one is for string, and there's only one sequential of the name, then there's no way to do that, obviously. And sometimes it's kind of a restriction we apply to this one. Of course, we can still argue that you can definitely create another name. That's definitely possible because there's no conflicts at all. You can say, oh, concatenate array, and another is concatenate a string. That's definitely possible. It's just in that case, there's no chance say, okay, we want a different name, but it's the same UDF name with different overloads. This is first example. The second example is when it comes to overloads, sometimes like we have applied for example, the distance to different type of the geographic points. One is 2D and one is 3D. In that case, because of name is sequential, then name have to takes the largest denominator here. It have to be x1, y1, z1, x2, y2, z2. Then when we look back at the 2D distance, it is a little bit confusing in that case because there's no way to put x2 here. It have to be z1. I think there could be other problems when we first had this function in our definition. Then this 3D use case come up, we want to put into the same one. Then it's even more problematic because in that case, this one have to be x2, which is a little bit confusing. Of course, you can always argue, you can say, okay, distance 3D, distance 2D, then there's no problem. And the last one is, for example, if you have completely different meaning cross overloads, sometimes this happens for the overloads. The second parameter here, for example, the first parameter and the second parameter will have different meanings. In that case, there's no way to explore that because we actually enforce the name across multiple overloads. So they do not represent different semantics. That's a 3 example I post here. Again, I'm saying if we are okay with change the name, that's definitely fine. But if we want overloads to represent multiple, like 2D, 3D applied to the same one, then it could be a problem. And I did a little bit research on the industry practice, most programming language, Java, Python, C++. Maybe they are not a very good example because Java does not support named parameter call. Python has very limited one. There's one library you can basically say, okay, single dispatch only overloads on the first one, first parameter, and rest of parameters never overloadable. The Python, I'm also test a little bit about how Python works in that way. Looks like it doesn't it doesn't require the global nameless as well. And for database system, I researched a little bit on the Postgres Snowflake, and they does not have this restriction, and they can definitely create different name. For example, this is Postgres example. You can add X, Y as an integer, or add the AB as a numeric, and they all works. You just name the invocation, and this is Snowflake example, which is very similar. And the way I didn't do Spark and Trino is Spark right now does not support the UDF overloads at all, but for the temporary UDF registration, and Trino only support the positional invocation, so they are not applicable. Yeah, I'm gonna pause here, see if there's any question or discussion. Right?
I'm reasonably convinced that simplifying this by requiring a single set of names is probably not the best solution. I think the second example and the research on what other databases allow is pretty convincing. That said, that brings us back to we need a solution for, like, how do you reasonably have different parameter names per overload with defaults and then have reasonable function resolution there. And I think that that's probably a good thing to address. I think if I interpreted this correctly, what other systems do is use positional, they require positional arguments to come first, and then apply defaults and named arguments. And so that's sort of in the same spirit, right? We need to have some way of simplifying this space so that, you know, it's not just a global search and you get what you get because engines all resolve these things differently. I think the main thing I'm looking for is how do we make sure that we are reasonably consistent across engines so that you don't get vastly different results because one overload versus another was called.
Thanks. Yeah, I think that's really cool. That Stephen, you wanna? Yeah, you can go first.
Yeah, I think if there's ambiguity in the named invocation, let's say that's the example case that Ross also mentioned, like X, Y, if they are different order, I think during the invocation we can fail. Right. If there's no ambiguity in name, that's a overload, there's no collision, then there's no ambiguity. But if there's ambiguity, we can fail in the invocation time. I mean, without the globalist.
Yeah, I think we would have to fail in that case anyway, because even purely positional invocations are going to not be able to determine which one to use. And rather than say, like, just pick at random, I think, you know, for consistency across engines, we don't want it to be like some engines choose the first one, some engines choose the last one. It needs to be hopefully consistent.
Russell?
Yeah, I mean, that's the main thing I'm worried about is we get into this situation where when you add a function, you have to do a lot of checks to make sure that it can actually validly be invoked, given all of the other definitions that are currently in the override, which I guess is tractable. So I'm not super worried about that. But the example 3, I think Yufei and I, we talked about this a little before, is I really don't like that being available in a database UDF. Can you scroll up to it? Just because we were going over this with how Snowflake has implemented it. And it's I could quiz you all on what literals put into that function might do, and you would not be able to guess which one of those is called. Like if you put in a float, which one are you going to get? Depends on what float you put in, apparently. Like there's all these kind of weird casting rules that happen inside of engines that will get you to a point where, like, if you're trying to differentiate functions based on type like this, you've lost already. Like there's no way an engine can get good behavior here.
So what is the conclusion then? Because we could say, and I'm very reluctant to go here, but we could say, like, these are the rules for matching functions. I actually, like, if we ignore named parameters, if we ignore defaults and just say, you know, our initial position was, if you have string string and string int, it's up to the casting rules of the engine to determine how to handle float, whether you can handle float. And so I'm kind of reluctant to even try and address that itself.
Yeah, I think this has been discussed a little bit before. So in general, we're still trying to say, okay, the type, parameter type plus its order is still the signature of the UDF and across multiple overloads. The engine will do their best to match. The exact match always come the first priority, then come to the kind of numeric conversion. Happens sometimes. I know this a little bit, like multiple engine can do its own stuff, but still the first rule is very clear. If you have the exact match, you have to you will do that exact match. In that case, here we have string and a string int will be in much good position. The other thing not in good position is we have the int and float. Sometimes the numerator enlarging kick in, and it makes it a little bit tricky to maybe anyone behave a little bit different across them. That's a little bit tricky. But yeah, I agree with Ryan. So this is something we might not want to put as rule there.
On the other hand, like I think if we're saying that you get these positional functions and, you know, it's up to engines to determine which one to call if they don't have an exact type match. That was what led us to this, like, well, let's treat named arguments as something that we can, before finding the overload, map into positions. Right, and that I think just does not work for the reasons cited here. It's weird for users. Number one, you have this odd case where you actually do want to move things around in overloads, like semantically. Number two, and then, you know, number three, I don't have too big a problem with, but, like, you know, we know that there are those issues. So I think it comes down to, like, what is the solution? Is it to match positional, then match name? Is it, like, to punt on this and leave it up to engines, which I very much doubt? Like, what is the alternative?
Yeah, I think the Paul convention is it's something we try to put a rule or a hint for engines. Like in the current PR, there's one section say, okay, which one get first, right? They always do the exact match as the first priority. Then if numeric enlarging happens, it's still allowed. And it's kind of a recommendation for the engine. I know this could be something there, but it's really harder to control and put some rule to forbidden or make that really clear across multiple engines.
I mean, what we're essentially writing, though, is like what is the correct order of resolution and what functions we won't allow you to add. right? Because like Spark only does named and Trino only does positional right now. Is that correct?
Yes. So Spark for temporary UDF registration only name matters. There's no way to overload them. Every time you register a new one, it will definitely override the previous one. That's what happens within the Spark. And the trainer does not support named function named parameter list parameter invocation. So there's no issue about that. Even you have different names, it doesn't matter for Trino.
But that's also, at least for Spark, we can consider that the behavior of the built-in sort of session catalog. What we're talking about here is actually passing everything through to the catalog, and then the catalog actually does, because we have this like unbound load and then a binding step where you pass in the invocation type, right? So I think that, well, we would have to see, because I don't even know if that supports like switching around parameters, but like that does support a version of this that doesn't just blow away overloads and things. So Spark actually has the two modes, right? There's the current create function syntax and behavior, and then there's also this you know, the DSV2 function loading that behaves a little differently and actually delegates way more to the catalog.
Yeah, I think so. If we create one node within the Spark, then you actually can get a run of the UDF, temporary UDF registration by still doing the overloads every time you go to the catalogs and pick one of the overloads. When you create that node for this Spark, that's still possible. Yeah, so come back to the resolution algorithm when we have multiple overloads with global main list. I think to assumption we have to provide before we go to these discussions. First, the default always do be tail. Like a default value will never go to in the middle of one function call. One function definition. This is actually every single engine. If they provide default value, they do that. I've already put that rule in the PR, UDF spec PR. And the second is when it comes to the call convention, the positional call, like there's three different models. If you look at here, like so I can put a 3 here. So there's three different models here. First, like Trino, you can all with positional call, which is no name at all in your UDF call. In that case, it's a little bit simpler, like because name doesn't matter in that case, right? The second is you can go with all named call, and what happens is let me go through three options. So the third option is mixed call, which is a little bit more complicated. So mixed call means you can go positional as well as the named invocation. Most of the case, like when I look at all these engine behaviors, the positional argument must come first. Because once the position argument go later, like after the name, then you kind of lose the position. What if you accidentally put this like second names on the first, then there's no way to find the right position. So positional argument always come first. Then if you want to mix, and then you put a name after that. So this is the three different model when it goes to the call convention. And for the second one, do you guys have any questions or for this one?
I think I would just point out here, you know, like I take Russell's argument seriously here that it sucks that a float might be cast to an int and might be cast to a string. But I think in the time we've spent since we since that was pointed out, I was thinking like we can't get into casting rules, right? Like we can't have different casting rules required for this than for other things in an engine, right? Like engines have to be in control of their own type casting rules. And so I think that number one, like we have to delegate to the engine to say, these are the type, tuples that you have available, you figure out which one. So I'm coming back around to like, I think that's really an important piece of this.
I think that's fair. My only argument against is if we have a global name list, it becomes much harder to write a function that's semantically different because you have a parameter which is either like an int or a decimal, but they're going to have the same name. So that like basically tells you that you can't have them serve completely different purposes. But
are you in favor of the global name list?
I kind of am. I was kind of convinced that it makes it easier for us to like reject functions that we don't want to have, that would be ambiguous. Like I'm 100% in agreement that this proposal without global name list lets you cover a whole lot more things, but it also puts us in a position where we do let users make things that are way more confusing, where like the behaviors are going to be very strangely defined, and what is an engine supposed to do becomes a much harder question.
So I guess in that case, and we should probably go through this first to understand it well, but I'm wondering what the failure scenarios are for this algorithm instead of the global name list supports. Now, I do sort of get your point, and that's what I liked about the global name list in the first place. And I could be convinced to go back to that while people want to use the same parse method name, right? Like it's not that bad to say value versus input, right? On the other hand, I also, that would actually be better if it were format and value, because then they're in different places. In any case, and I kind of agree that like if you're doing semantically different things, why are these overloads of the same function? And I don't know, like we're governing them as the same function, right? Why would you govern, string concat and array concat the same way? Those, if they're semantically different things, then different people should probably be able to call them. So I think that there is an argument for the like global name list. It just seems more restrictive than necessary. And so if there is a reasonable path forward without it, I think we should take that.
That's fair. I mean, let me paste one thing in chat just so everyone can see what I think is my most terrifying example of like what you could write, which is you can do this. You can write these two functions as overloads. If there is no global name list, there's nothing stopping you from saying the first name parameter of the single version is a completely different thing than the 2-op1, and now we can write these kind of super dangerous things. Now that said, most languages let you do this, so I'm not sure this is the right place to take a stand and say we need to stop this sort of thing. I just want to go in eyes wide open.
So
I was wondering. Sorry, I think the previous discussion around like whether we put a difference like semantic like English string and a precision with different meaning onto the same UDF. What we can say is actually go against the overload idea, the whole overload idea. Like we can say we make it simple that there's no overloads, then a lot of the issue will be way much simpler. And if we want to go to the overload, I think this is the place we are right now. Like if we say no overloads, I think that's still a nice solution for the UDF.
Okay, that I'm glad we're getting it all out there. To Russell's point about most languages allow you to do this, I want to point out that I disagree, at least in programming languages. You get overloads or you get default and optional parameters. You don't get both. So, I mean, that was the original idea behind a fixed parameter list, is like in Python, you get a single function definition and that's it. Right? And you have the same names for everything. And sometimes, yeah, you say this or that in your, like, I think in our own Python API for load table, it is, name or identifier or something like that, because we accept both a tuple of strings or a string. And so like that's a thing for us to say, like, hey, this is sometimes treated as a name, sometimes treated as an identifier. I think that where we're getting into trouble is that we're trying to mix the two, right? You have Java does overloads, but no defaults and no optional parameters. And then you've got the other. And so mixing those together is where it gets real ugly. However, to Yufei's point here, I think that overloads is the most natural way of proceeding, because we're talking about a very limited language that is not a programming language in procedural, right? Because it's way easier to say distance, but like you're in your distance example, when you're actually implementing it, it is x1 times x2 plus y1 times y2. Sorry, no. x2 minus x1 squared. Whatever, but like if you're implementing these distance functions, right, you're squaring the distance between x1 and x2, squaring the distance between y1 and y2, and taking the square root of the whole thing. And it is way easier to do that than to think, okay, well, what do I need these parameters to default to in the case where I don't have them, right? Or worry about, hey, how do I have a Z1 that doesn't exist in this call, right? Like you want these two things. And I would argue that if you're just giving an expression fragment, the easiest way to implement these is to use overloads.
Yeah, I think the in terms of ending behaviors, for example, just take one example. I know it's Snowflake, it may be a little biased. So Snowflake does not support mixed invocation between positional invoke and named arguments invoke. That makes the Snowflake a little bit better, like, because if we want to allow this, for example, named invocation as well as positional invocation, we have to have some restriction. Otherwise, the resolution algorithm was crazy. Like, there's too much thing to think about, and it's too complex to reason about. So we have to apply some restriction somewhere, like some ending did that, certain system do that. Like Snowflake does not support mixed. I think maybe that's one of the issue that when it comes to even if you want to support, then it's become very problematic.
Is that an option for us? Positional or named, but not both? Because it seems to me that positional is always easy. Like, well understood, we get it, easy. Even default values, because you can only default things at the end of the parameter list. Named is kind of the same thing, right? You've got all the functions where you can take your named arguments, turn them into, positional arguments. If there are any gaps in names and there are defaults, you got those, and then you choose one of those functions. I mean, like, maybe mixed positional and named args are just a bad thing to do. And we say, if you choose to do it, you're on your own. That could be a very reasonable way to simplify this.
Yeah, this is actually my very original, like when I wrote these docs, I think I only have 2 points, which is quite try to assume that there's no mixed invocation. In that way, we simplify a lot because you cannot really do that. Even the tier one makes the algorithm much more complex.
I think what I'm saying is I'm good with either fully restricting that or going with step 3, which I think is also deterministic.
So if it with the step 3, is it more complicated or significantly more complicated, or it's just minorly? So it's mildly more complicated.
When it comes to step 3, you first have to match with the positioner, which is, I think it's fine because positioner is way simpler. Then it comes to, once you resolve all these positional parameters, you go to the named parameters. Then you can kind of do the exact same as a step 2 to try to resolve them, because you basically throw the first certain parameters or for all overloads. So I am not, it's a little bit more complex, but not dramatic. Like,
Yeah.
So there are failure cases for step 3. So for instance, if I have a string double yx versus string int xy, right? So the type of my second argument and potentially a casted type of my second argument determines whether my, third and fourth arguments are xy versus yx. Like technically, if I, pass a double in there, it's yx. But that, so we do have very confusing cases if we do this.
Does that means, for example, for this use case, we throw the first one, because let's assume the first always positioner invocation, we throw in the first overload xy, we throw x when we come to the named invocation. The second case, we throw y. Then when you come to the named invocation, if you see y there, there's no way go to the second one because y is already thrown away.
No, I'm saying okay, so we have 2 definitions, say double yx and long xy, right? So depending on what I put in the first positional parameter, I eliminate the ambiguity, right? I select from the first positional parameter either the yx function or the xy function. That seems real wacky to me, but on the other hand, it is deterministic, and we can tell engines, yeah, that is how you do it, right? You match that positional parameter first, you select the functions for that match, and if that's how a user has defined this, we could also interpret this as there is no position in the last 2 parameters, and you're always going to pass them as either defaults or named parameters. And so this is just a way of making it easier to call. I think it just comes down to a judgment call. I would almost, if it were, I think one of the easier things to do would be, if we're going to simplify this and do something later, do the first 2 and then add on mixed later, when we can, think about more clearly, do we want mixed to be there? Or is anyone even complaining that it's not?
I think it's reasonable to maybe delay the third option a little bit in this moment. Just to, I want to share a little bit more context, because I dedicated not putting the default value into this algorithm because it makes things way complex. So I don't want to get to the very complex like discussion, but it will add complex into the resolution for sure. When especially for the third case, I think. So I think maybe it's reasonable to say, okay, right now only case 1 and case 2, we can think about third case in the future.
And I think for reference, that also matches our position on parameter invocation for stored procedures. We support either positional or named, but not a mixture of both. For probably this reason, I didn't ask Anton. But he's a smart guy. He probably saw this coming.
Thanks for confirmation. Yeah, cool. That's I think that's almost conclude the global parameter name list discussion. Any other question, concern, feedback? All right. Then we can go to the.
I just want to say thank you. Like, this is a very complicated thing to like present and get through, and it's good to like circle back and have a decision here. So thanks for leading us on this one.
Thank you everyone for the feedbacks. I think the next topic I want to mention is whether we want to support the default value within the UDF. Let me actually open up another. Okay. Can you guys let me enlarge a little bit? So I don't have any doc for this. I want to go through the certain example when it comes to how do we resolve the ambiguity when it comes to the definition. All right. So default value, as I said before, so we want to put, like, if we want to support default value, I think a reasonable restriction here is you only put default value at the tail. In this case, you can put the first parameter does not have default value, and the second, the third has default value. And if you want to, like, there's no way say you put default value in the middle, and for this third one, you don't have default value, because it's really confusing and it causes more ambiguity when it comes to definition as well as the call convention. Then there's something really interesting happens because when we have something like this int flow string and the last two has default value, then it will yield these following signature, which I think makes sense here. But when I look at the SQL standard, there's some standard only support the positioner call convention. This one is actually allowed. So it's very interesting. This one is actually allowed because I think if that's positioner, like there's no named invocation, then this one is fine to have as there's no ambiguity there.
I think you could, if you had parameter names, you could also invoke this way, right? So if we have X, Y, and Z for our parameter names, I could do foo of X is 1, Z is, B, and then when I fill that in, I have in position 0, I have a value. In position 2, I have a value. And then I have a default for position 1. Does that make sense? So I think that you could simulate line 146 with named parameters as well. And that would be something that we would probably want to support.
So we still allow this. We think this is not one of the arteries has been yielded by this one, right? So this we can create new overloads with this signature, right?
I would say we could, as long as we had a rule that you should prefer functions that don't require defaults over functions that do. Right, so you could have a foo of int string, and when you get the call foo of int string, then you say, oh, okay, well, I can see that that's the one I should use over the one where I am using foo of int string and defaulting a float. Not sure I'm convincing myself here, because this brings in more ambiguous cases, right? Because I could have foo of int string calling a foo of int float string, or a foo of int date string. And in both cases, like we're creating ambiguous things. I mean, but we have that problem anyway, if we had foo of int float and foo of int string. So I guess the question is, if there are more than one, if because of defaults there are more than one potential function call, how do we specify which one you use?
Yeah.
So what if the third parameter is also float? Then if you allow line for 146, that's kind of, then that would be
so
ambiguous.
I think that's if third parameter is float, then 145 and 146 later is same, right? You're gonna ban them anyways.
Which one you're gonna bind to second or third argument? That'd be ambiguity.
Third argument, because, well, if you're calling in positional, you consume the positions first. And so you would default the third argument. If you're calling by name, then you could select it by name, which one you're actually supplying supplying something for. So defaults create these situations where you might have more than one option where you could resolve the function, but then have, multiple defaults that you could call. I think we can either say, choose one arbitrarily and you get what you get, which I'm not a fan of. We could say fail if there are multiple options that can be called by filling in defaults. I'm kind of a fan of that one. Or we could pick some arbitrary rule for doing it. I'm not a fan of arbitrary rule, because then people are going to disagree and just do their own thing. So I would say probably fail if there are multiple options and you can't choose one.
When you say fail, do you mean the engine fails, or do we fail to allow someone to make that situation possible?
Oh, that's a good call.
That's where I think all this breaks down. Are we responsible for figuring this out?
Yeah, I think there's two dimensions for UDF. First is when UDF is being created, like every time create new overloads, do we allow them or not?
So
And
I would
say-
say
Yeah.
don't allow them, because I think that we can take anything with defaults. Okay, at least for positional, we can take anything with defaults and say, if I call it with this number of parameters, I can get these things, right? Like we can enumerate from this foo of int float string, foo of int float, foo of int string, foo of int float string, right? Like we can have rules for enumerating the signatures that are occupied by that overload. I am not confident that we want to perform the same analysis with named arguments, though. Because named arguments, like I said, you could, well, then you basically have, I guess, the subset of names that are supplied. And you could go through and say, okay, I think you could do the same analysis based on the names that are supplied. Right? Like, take all the names, remove the required names that, you know, that are not defaulted. And then you have this, like, hey, this could be, any one of these names could be missing. And so we, you know, basically you could do this same analysis rather than with positions, but with sets of names. Right? If I have A, B, C, and they all have defaults, I could have the situation where you supply ABC, AB, AC, BC, A, B, or C. It's just the complexity and number of combinations skyrockets.
And we're promising we're never doing a mix of position and name to that, because that makes it really
That makes it even harder, yes.
Yeah.
So that's where the defaults comes in. We have to say at this point then, if we're going to do defaults and that kind of lockout, we are not allowing you to, you have to either do positional based resolution or name based resolution.
Yeah, I think that makes sense, especially if you look at the like Spark procedure, you can actually pick one of them, like missing another when you go to the procedure call by named invocation, right?
Okay, so I think let's back up to the discussion of what should we do? Should we fail at definition time? Should we fail at invocation time? Definition time means we have to do this very expensive analysis, figuring out all of the calls that are occupied by a given signature. On the other hand, if we did it at invocation time, that's relatively easy. You do your analysis. If you come up with two options, you fail. And that is the user's problem. And you say, hey, you either need to supply the following, you know, additional parameters. We have int float and int string. You've got to provide either a float or a string. That's it.
Mm-hmm.
Or we have this big analysis problem. I would probably say you're going to have to do the failure anyway, because I don't trust people to do this analysis and reject it.
Oh, can we do both? Because I think when we add the definition, we can do the expensive, because that's one time and one time cost.
That's actually the current spec is, for example, if you define these overloads, then it will yield these 4 different signatures already occupied. Is that okay? Occupied. Then once you create a new overloads, then it will just say, okay, this is occupied. It's not allowed to create new one with that. In that case, I think it's fine. Like in terms of complexity, it's fine to prevent this as the definition times. At the same time, I think for the call convention, I agree with Ryan. Maybe the engine should, because even you block here, there still could be some ambiguity when it comes to call convention. Then engine will have to like fare faster.
Yeah, so we try to prevent the issue during definition time, but in case we cannot, still during read time, we still fail.
So the reason that I would want to fail at definition time, if we could, is that we then avoid the situation where an engine decides to just make an arbitrary choice, and that becomes the behavior that everyone else has to kind of then follow. If instead you can say, like, this is invalid because we know that this will be ambiguous, because I think this is what I don't know if you've looked through the Snowflake thing, but I think Snowflake just chooses at some point when it's in this ambiguous state. It like doesn't fail. It lets you keep making things, and if you make a call that's ambiguous, it just picks one.
Yeah, I think it's what happens to the most engine, including Snowflake and Python. Like you can do a single dispatch is it does not report error when you create that function, but in the backend, it's actually overloads. That's what happens. So that's a little bit. I mean, in this
Not a
situation,
bad idea, actually.
Just say you can only override the existing one.
No, okay, so I think there's an idea there. So what if in order to implement defaults, you must go and do the substitution on your SQL and put in overloads, right? Like, why does the spec here need to support default values when a default value is really just a minor modification to the SQL that you're putting in?
So I don't know if you put this out here. There's this idea of null passing in engine.
yeah, it's here.
So if you have null on input, whether you null out the entire function, like it's a monad or something, versus that should be put into the function itself. So like there are different engine behaviors of how they want to deal with the UDF, which I feel like makes that harder to do. Because like that's what I suggested for this behavior, is that if an engine wants to have one of these different behaviors, the UDF writer writes into their implementation of the UDF what they think the engine behavior should, or corresponding to the engine behavior, where like if null, return null or something like that.
So, I mean, I think you can still, I don't know that these are two things are the same example. At least I don't understand the connection here, unless your conclusion is we don't need any on null, return null thing, because the engine can do that analysis and conclude it itself.
That's kind of what I was thinking, is like, is this something that the UDF actually knows? Because it's actually just a hint to the engine to optimize. Like you could do the exact same behavior again by implementing it directly in the UDF body. So
I think that the difference here, and maybe this isn't a difference. So yeah, you should be able to do this analysis and determine, because like I don't think any user is going to do this, right? So this is an analysis hint at creation time for like, hey, if any input is null, just null out the output, right? That also helps if you have like a Python, some other language can't be so easily analyzed. Now bringing that back to default parameters, it makes sense to me that at least with SQL you would be able to do that substitution and like just replace the expression name, and if you support that, you need to be able to produce SQL with that substitution already done. That's also reasonable for humans, right? Because if a human is performing these overloads, then a human can do the substitution, and if they miss one, then we can easily tell that it's invalid, and like, hey, there is no parameter A, and they can tell that they should have done that substitution. So I think a valid solution to this is just require, if you have syntactic sugar for default values here, the engine needs to translate those into multiple overloads. That also like simplifies our resolution problem by getting rid of default values. And so that every signature or every definition has one and only one signature. I kind of like that. In terms of like, does that substitution thing work when you also have embedded Python? I think it kind of does. Because your
just
Python would have the, I don't know.
just want to understanding better. This is things we don't.
We're over time and I have to go. I'm sorry.
All right, then. All
Okay.
right. Thanks, everyone. Russell, I'm not
I
sure.
think what Ryan was getting at is basically the currying approach that I think I was talking about before, where like you are not allowed to write foo x. If you write foo xy default 5 or something like this, you actually are writing foo x with a body that says y equals 5. And then you also write a function foo xy.
Well, I think for the default value, what one thing,
Like this. Sorry, I sent it in Slack. So the engine says I want to support default values, and then this is how you support them, which is basically what Scala does. You say you've put in a default, but we're not actually making a default. We just make all of the sub functions that are required under the hood. And then there's no resolution problems now because we have basically global ordering for everything within a default. Like you cannot have another function now that looks like this.
I think that makes sense. Thanks, Russell. In that case, we just say default is just a hint here, and it's completely up to the user to do the substitution when they provide the function body. If you want to do that, please do that. If you don't, then it's on your own.
so
Right.
Not use the engine. Let's say if engine support default value, engine is supposed to generate all the signatures. That's
So
why-
basically, yeah. So like if Spark does this, then Spark has to act like the Scala compiler and actually make all the different functions that are required to satisfy this optional call.
Yeah, so engine will do that, but from the Iceberg UDF spec itself, it does not provide any guarantee, okay, this default will be always like, it does not.
Yeah. It's not encoded into the UDF. It's in the
I
UDF
see.
body.
The question is, in that case, we cannot provide any values, right?
You don't. The defaults themselves are encoded in the bodies of the functions.
For example, yeah, there is no
So if you
value. Default A will be empty. Like if you want to provide a default, it's just a default name, but there's no value.
Well, the idea is that we don't encode that at all. The Iceberg UDF doesn't know that there is a default. It's only in the user's embedded body that the actual default appears. So if you're in an engine and you make something, you can make something and use a syntax with default, but then the underlying Iceberg UDF that's created does not have a default embedded in it. It just has bodies that have a default parameter as part of them.
So my question is, yeah, I get that. My question is when it comes to the the right? Let's say I'm a Postgres user, I write the default into this UDF and it's preserved within the Iceberg REST catalog. Then when it comes to another, like for example, another Postgres instance come to visit this UDF, how does it know there's one default in the signature? Like it will never know, right?
It will never know. So the problem with this approach is the same as the other naming approach, right? Is that you can then not have a foo xy and foo xyz that behave differently. Like those two have to have the same underlying code.
Yeah, that's kind of, for me, that's kind of literally saying we don't support value. Support default value, because there's no way for like next time another engine application like Spark application or Postgres Snowflake expression pick that up and say, okay, when I look at this signature of this UDF, there's one default value there.
Yeah, I mean, you don't know there's a default value. You just see that there's multiple function calls. Because like a caller doesn't call knowing there's a default value. The caller just calls a function name. So you could construct it so that it behaves like it has default values. But if you do that, you're giving up your ability to overload other names of the functions that are children of that default value. Like you basically are taking up that function space. And Ryan, so that's basically what you have in your proposal. But instead of checking that, we say that the engine has to physically take up all of that space. Like it has to make up the functions that cover all of the optional invocations. So the Iceberg UDF itself has basically blocked the ability to make conflicting ones by populating all of those spaces.
Yeah, if I think that's the Iceberg UDF doesn't support default. It's all engines.
I think this literally say for this spec, especially when we're talking about this UDF spec, we say, okay, no default is supported. No default value is supported.
Yeah, I mean, you can check how Scala does these, because that's basically what we would be doing, is we would be prohibiting them by writing out all of these functions in a way that there's no way to put an overlap. You can't make an ambiguous one.
Got you. Yeah, thanks. We are 12 minutes over. Thanks everyone for joining this conversation. It's really helpful. I'll make some changes afterwards, and we'll see you next time. Thank you. Bye.